Hello and welcome to the ISJ Leaders in Security podcast. My name is James Thorpe and I'm the editor of International Security Journal. In today's episode, I'm delighted to be joined by Seagate's Andy Palmer as well as Rob Lay from the Secure Logiq team. In today's discussion, we're exploring the role data storage plays in the development and operation of AI systems. As the foundation for data accessibility and quality, storage infrastructure directly shapes AI performance and trustworthiness. Today we'll be examining the concept of data gravity, which Andy's going to talk us through in a little bit, and also why hard drives deserve more attention. And also we're going to be exploring how modern storage technologies are actually evolving to meet rising demands. In addition to all this, we'll also consider the challenges that organizations face in building reliable AI, and also how the relationship between AI and storage itself may transform over the next decade. Fantastic to be joined by both of you today, guys. How are you both, and where are you calling from today?
Hi, James. It's Andy here. So I'm from Seagate. I'm located in a village just outside of Bath in the southwest.
Fantastic. And what about yourself, Robert?
I'm Robert Lay from Secure Logiq. I'm our product manager. I'm calling currently from sunny Portsmouth. Glad to be here. Thanks for having us.
Fantastic, guys, and thank you so much for joining the discussion today. Obviously, we're going to be looking at quite a lot of technical elements, but also looking at some of the key trends in the industry as well, and hearing both your perspectives on some of these key talking points. So I want to start by looking at something which sounds quite broad, but I think is obviously kind of pivotal, not just to this conversation, but underpins so much of our industry right now in this technology space. And that's exploring the role of data storage and how it plays a role in the development and operation of AI systems. So Andy, I want to come to you to start with. Can you tell us a little bit about what your thoughts are on this talking point, please?
Yeah, of course. So AI depends on data. And the more data you have, the richer the outcomes and the better the outcomes will be when you're interacting with AI. So right now we think that AI is really a GPU market, as we're very much in the sort of learning and development phase of AI. But as it becomes more popular, socializes, has more applications, it will rely on data sets, and those data sets need to be stored somewhere, and that's when it becomes a very big storage market for Seagate and other storage vendors.
Fantastic. Is there anything you want to add there, Robert?
Yeah, I think from our perspective, we do a lot with video analytics companies, and obviously a lot of these are either machine learning or sort of AI models that have been trained on vast amounts of video, image, and audio data to be able to detect certain things, like if someone's wearing a backpack, if an object's been left for too long, if someone's crossing a line. And the training of these models, specifically with video, obviously video and images are much larger than text. So your LLMs that people are chatting to make pictures and write poems and all these other things are more trained on text, which is a much smaller data set. So yeah, from our perspective, we're working a lot with those, and as Andy mentioned, it's heavily CPU and GPU based in terms of when that system is deployed into the field. But yeah, there's obviously a storage element involved in there, especially with the training of these models.
Absolutely, and obviously, before we kind of look further at that relationship between the large data sets, but also that storage infrastructure, there's a really good quote which I've got a note of here, which is AI is only as good as the data it learns from, and that kind of follows on from what we were talking about there, and that leads me into talking about how that infrastructure influences the quality and also the accessibility of that data. Tell us a little bit more about that, please.
Yeah.
Go on, Andy.
Okay. For us, data storage, it's a fine line, because the trade-off is keeping it secure and yet at the same time keeping it accessible, and that poses the big challenge, because there's no point having the data if you can't use it, right? But equally, there's no point using the data if by doing so you make it vulnerable and the AI outcome is somehow skewed because someone's got in and messed you around. So the infrastructure relies on security, and you'd expect it to be encrypted. You'd expect it to be cognizant of which IP addresses are accessing the data. You'd expect it to be air gapped at some point as well for archive purposes. Yeah, at the same time, users demand it locally, so it has to be available in a place where they can reach it without any sort of lags or anything. And so designing that infrastructure, it is very difficult, but it is being done, right? No one can put their hand up and say, yes, we are totally secure. But, those who do shouldn't be believed.
Yeah.
But equally, it's about the trade-off, as I say, between accessibility and security.
Fantastic. And Rob, is that something you wanted to add there at the start?
No. I just thought I'd let Andy take the lead on that. But I guess the thing about the storage for specifically training these models, it's a massive data set. It's enormous. So cost per terabyte has to be taken into account. So speed is preferable, but hard drives are probably the most cost-effective way to store that volume of data, petabytes and petabytes worth of information. And then, you've got the accessibility point, which Andy mentioned about. It needs to be easily accessible, not just for reading purposes, but this data these models are trained on is constantly needs to be updated. So for a long time, for example, ChatGPT had this big message at the bottom says something like data in this model was only trained up until 21 or something. So anything that happened after 21, it had no idea about. So you'd be asking it questions and it wouldn't have a clue about, who the latest president was or this, that, and everything else. That point of being able to be fast, accessible in terms of being able to kept up to date and probably organized. So like organized data is probably incredibly valuable in terms of how these models can be trained from these massive data sets.
Absolutely.
Yeah. I think the art there is, on the data quality, isn't it? It's removing duplications, removing biases, and orchestrate the data to make it as good as it can be. Because, as Robert said, the outcomes depend on the data.
Yeah, absolutely. And Andy, I'm just stick with you on this idea of training and performance as well. A lot of Seagate's articles have discussed this concept of data gravity. I was wondering if, for our listeners, you can give a little bit of clarity into why that matters and what that actually means when it comes to AI training and performance specifically, please.
Yes. So data gravity has various descriptions. The most common one is that data, just by being there, pulls in applications, has a gravitational pull, much like a planet, and it pulls in, resources for computing, for cybersecurity, and so on. And that's absolutely true. I think in a Seagate context, we talk about data moving from hot data, as in use, to cold data, as in storage. And if you think that most data is cool to cold data in the world, and that part of it is growing the fastest, that has implications for the kind of medium that you would choose to store your data on. And there has been a lot of discussion in the past about SSDs displacing completely hard drives. And what that sort of supposition ignores is the fact that IT managers want to use their IT budgets in the most effective way, and having all your data stored on the most expensive medium is not cost effective. And that's why, far from us saying, well, it's that product or that product, we say that in IT infrastructures, it's a blend of technologies optimized for performance at one end, but cost optimization is a vitally critical part as well.
Absolutely. So why should we be paying more attention to the role of hard drives in this cycle, Andy?
Rather than hard drives per se, let's talk about let's talk about hard drives in a minute. But storage is vitally important. It's moving from being a grudge purchase to being a strategic purchase.
Okay.
Because so many companies are defined by their data, and so many companies are actually data companies. Even if you think that they might be, manufacturing aircraft engines, what they're doing is engine as a service, and to make the best use of that engine in flight, it's transmitting data about its performance. So when it lands, for example, the right spare parts, the right tooling is available, at the receiving airport to change the widget over so that the aircraft can get back in the air as soon as possible. So therefore, you can almost argue that it's a data company. So the role of hard drives is about mass capacity storage, and we have technologies which we could talk about, which would take us through 120 terabytes on a standard 3.5-inch drive. But why that's important is because the downside of all this data creation is the environment, right? There's lots of talks, and you can almost imagine the brakes being put onto AI development by the fact that powering the stuff, storing the stuff, is becoming more and more of a challenge. There's a lot more talk in the press about, should it be costing the Earth? And so what we set out to do with our technology is maximize something called areal density. What areal density is how much data can you get onto each platter within the hard drive. And so we've just launched our 30 terabyte. And if you would compare that to let's say a 16 terabyte, so roughly half the capacity, what you're doing is you're doubling the density. So your terabytes per square meter are doubling, but it also takes the same power to spin one of those 30 terabyte drives as it does to spin a 16 terabyte drive. So terabytes per watt is also doubling. And this for us is vitally important, and it's a big contribution to any company's environmental strategy.
That's really interesting. And Rob, with your secure Logic hat on, is there anything you want to add there yourself?
Yeah, I think Andy covered most of it, but I'd say the hard drive is the unsung hero of many things, including AI.
Thank you.
Because if you looked at a hard drive today and one from 5 or 10 years ago, essentially in your hand they kind of look the same, right? So then, in a way, it's kind of not an exciting technology, but it's the key driver behind so much. Whether you're taking photos on your phone or anything else, it's all getting stored somewhere, like probably going to the cloud, which is ending up on someone's hard drive on someone's computer somewhere, hopefully a Seagate one. And I guess the only thing from our point of view, from the server side, which we also feel the server and desktop hardware has also been one of the unsung heroes in the CCTV industry. It sits in a rack in the back end. It's not very sexy. So it's one of those things where you need it to make everything else that is sexy run, the software and the nice cameras and the analytics and everything else. But it's an essential component, and kind of where we come in is you could have many hard drives, for example, but it's also the way they're configured as a storage array that's really important for both performance and reliability and longevity. Because once you do have these 30 terabyte drives, you've got 100 of them in a storage configuration, for example. You probably really don't want to lose that data.
Yeah.
Because that's a huge amount of data. So whether it's backups or RAID configurations and everything, that's kind of our specialist area is making sure that everything's configured in a way that the building blocks of the system, like the hard drives and the processors and the graphics card, are built in a way that's reliable, highly performant, and good longevity for the system. So you get your money's worth.
Fantastic. And Rob, I'll just stay with you quickly before I come back to you, Andy. I mean, we talked about reliability and configuration there, but Andy, you also touched on this side of organisations becoming almost data organisations now, and that is something obviously we're seeing across the market in general. So, Rob, just coming to you quickly, what kind of challenges do organisations face when they're ensuring that potentially AI systems aren't just reliable and powerful, but also trustworthy? I mean, that's a key word that I want to chuck in there as well.
That's a hell of a question. I would say there's a lot of people now working on sort of policies and protections for how AI can be used, should be used. It's a difficult question, really. I'm not sure I have the best answer for it in terms of your general average company in the UK, for example. They probably aren't hosting their own AI-based data, but they're probably using online tools.
Yeah.
But I would imagine there's going to be a huge amount of policing and policy coming out around all of AI and the data that governs it. We've already seen things, for example, like the authors of books are trying to sue OpenAI for basically consuming their data and training their models. So you essentially could probably get AI to rewrite a whole book.
Yeah.
So you wouldn't have to buy the book or that sort of thing. So I'm not sure if I've given you the best answer there, James.
You're all okay.
It's going to be an evolving landscape, I would have thought, as things go forward and people incorporate these tools more deeply into their businesses.
Fantastic.
Yeah, I think it's much more than just buying an app, right? I've literally had someone say to me, I want some AI. And I said, I don't know what you mean. I can just sort of talk about Seagate, and we are embracing AI across an awful lot of our processes, manufacturing and quality control and testing being the obvious ones, but just in the sort of sales and marketing, the go-to-market organization, we're all being trained on AI tools, and really it's how we've organized around it. So it's things like training of staff, okay, things like making sure that by using AI tools, we're not infringing on copyright law. That's really important to Seagate because we're a high integrity company, and so we've got to make sure that we're not infringing anything. But also what data is available, because if I searched up, I don't know, executive salaries, we don't want to be accessing HR files and displaying that across my screen. So there's an awful lot of thinking to be done rather than just saying, well, I want some AI because I've heard it's pretty cool. You've got to really structure your organization and your policies and training around the use of AI to protect the company. And increasingly we're seeing more and more regulations coming through. So for example, if a person uses AI to make a decision, then they need to keep a snapshot of the available data at the time of the decision available for regulatory purposes, for future scrutiny. And so that best practice then comes into play here, and having the right storage infrastructure to somewhere to put that snapshot easily without the user even knowing it's happening. It's just automatic. This becomes vitally important. So there's a lot of companies out there thinking about AI and thinking about, okay, it's a bigger thing than just an app. What do we need to do? And there's a lot of consulting opportunities out there for some of our partners.
One thing that did just occur to me is a lot of these free AI tools that anyone can basically use online will quite often tell you that what you're asking it will be used to help train further models. So if you are asking it something sensitive about your company, or you're feeding in an Excel document of your accounts or your cost pricing or something, you actually have no idea what OpenAI or Google Gemini is doing with that information. So I wouldn't be surprised if there's going to be a point where self-hosted models move into businesses so that you do have more control of where your data is going, which will mean, probably having an air-gapped or a self-contained LLM that's optimized for your business, that has access more specifically to your own data, documents and databases and that sort of thing as we go forward. Because that's definitely something to keep in mind. Once you upload that image or document to get your response from any of the LLMs, you actually don't know what's happening with that data behind the scenes. And quite often, if you read the small print, it will actually tell you, hey, we're going to use your questions to train the model further.
Yeah, and certainly Seagate created data. Even though we might use a well-known AI tool, to your point, Robert, that is air-gapped. It's not available outside of Seagate. Yeah. So we're not releasing our manufacturing data, for example, to the greater AI, and yet we all have access to presentation material, so that wherever it's built, created, we can download it and use it in our own presentations. We can search company policies very, very easily. Who's responsible for what? So it's a really useful tool, but you're right, it is air-gapped. It's not available to anybody outside of Seagate. And we think that kind of structured thinking is really important as we move forward. And I think we're at the point now where people are making parallel decisions. They're saying, right, what do we decide here normally, and what would AI tell us to do? Let's compare the two. and eventually they'll start to trust the AI model is as good as they are, and it will start to be used more and more frequently, and that's when it becomes vital. So now is the time to get ready for AI. Absolutely.
That's really interesting. It's interesting to hear you both also kind of talking about taking this more bespoke approach rather than just kind of applying, like you say earlier, Andy, kind of I need AI. It's like, well, that doesn't mean anything in that context. It's not a kind of one size fits all idea or concept of technology. So that's really insightful. Thank you for that, guys. Obviously, I want to move back to the kind of the storage itself, and also looking at hard drive specifically. We touched on it earlier. How is this technology kind of evolving to keep pace with some of these storage speed and reliability demands? Obviously, we're seeing so much growth in this area. Can you give us a bit of an insight into that, please?
For sure. I've already talked about areal density and capacity on the hard drives. We've got technologies which do things like spread the data in such a way that it minimizes the amount of seek time, so the amount of power, which is not productive. It's just moving the needle literally across the face of the platter, in the most efficient way possible. It's that sort of thinking, which actually has come from an AI application. It's that kind of efficiency that we're trying to drive. In addition, we are putting our drives into platforms.
Yeah.
And one of the challenges with high capacity drives is if a customer needs to or wants to do data protection, so normally they would achieve that via a RAID, a software RAID or a hardware RAID. But the issue with RAID is that it's very slow to rebuild drives if they go wrong. But there are many factors which dictate how long it takes to rebuild. But on the average, it's about 3 hours per terabyte.
Okay.
So that's a lot of time. It's a lot of downtime where the product's not being used. So what Seagate has done, we use our intimacy with the hard drives in our platforms, and hard drives all create data about their performance known as smart data. And our platforms could interact with the smart data, and it can predict when a hard drive goes wrong. And when it does go wrong, rather than turn off the whole drive, it can turn off individual platters within the stack, offload the data, try to reformat it, and then if it's successful, it can reload the data onto the platter. You don't lose performance because all the drives are contributing to this rebuild, all the spindles in the array. You don't lose capacity because we always reserve 2 drives worth of capacity across the array as well in stripes. And all that is done automatically with no user input and no input. It's all done within the enclosure. And that means that with our smart JBODs, I appreciate I'm pitching a little bit here, but it's effective. But with our smart JBODs, you don't need as much RAM and as much CPU as you do for a standard JBOD, for example. And plus, and the most important thing for the environment is that the drive remains in service, because there's 10 platters within a high capacity drive.
Yeah.
It remains in service, and the other 9.5 platters can be used still. And so that cuts down e-waste. So there's all those kinds of things that we've developed and launched that really sort of drive, help us unpack the complexity of data storage. And a lot of customers are using multi-cloud services as well. So they'll have a core cloud and then take the services best available or best suited from each of the other cloud providers. And we're part of that scene as well. We have our own storage, S3 object storage as a service as well. So you can see that as we look at data where it gets created at this sort of, the end piece where it goes through to the edge where it's first computed to where it finally gets stored.
Yeah.
Seagate has got a seamless integration of technologies which can help you store and move that data and protect it all the time. And that's where our thinking is, and that's what we're developing. And if I told you that beyond spinning disk, which currently has got lasers and near field transducers and plasma rays, if I told you that we have biologists on the payroll looking at things like DNA on a chip, You can see that we've got plans that looking at sort of 20, 30 years in the future.
That's really fascinating. Thank you for that, Andy. And I've been well and truly pitched. I'm sold. So thank you.
Get your order book out.
Rob, have you got anything you want to share with us on that point as well?
Yes, from our perspective, it's about understanding how the software works, whether it's AI or a different type of software, and how that data is being used. For example, we might pick SSDs to store metadata, and then we'll have in the same server we'll have an array of hard drives for storing video data. So we'll be understanding, how this data is being used, how everything's being processed to make sure that we can build and configure an optimized system based on the components. Alongside that, sort of touching on what Andy said, you mentioned 30 terabyte hard drives and the rebuild time in a RAID array. RAID arrays are really, really common in our industry. Most typically use hardware RAID arrays with a battery backup to make sure everything stays operational for as long as possible. But we don't always pick the biggest hard drives. They often are cheaper per terabyte, but we'll look at rebuild times. So, for example, rebuilding an array of 8 terabyte drives versus rebuilding an array of 20 terabyte drives. The one made up of 8 terabyte drives. So if a drive fails and you have to rebuild it, you're rebuilding the parity of 8 terabytes rather than 20. You lose a 20 terabyte drive, essentially you've lost 20 terabytes worth of data. So don't get me wrong, we do use big hard drives very often for bigger systems. But maybe the array will be split up in different ways, but it all comes down to the configuration. And I guess this is me pitching here. This is where we're the experts. Our biggest sort of, unique selling point is that we're kind of the experts in this configuration side of things for server hardware, most commonly for surveillance applications.
Yeah, and I have to say, it's really cool, working at Seagate, because we're the building block, right? Of a storage infrastructure, and we get to work with so many partners with so many different apps and ideas and things like that. So Robert's talking about a server designed for surveillance, and then we see the projects coming through, and it'll be some really interesting companies that are looking at this thing and then integrating access control and fire systems and face recognition, and and it becomes really interesting very, very quickly for us. And it's endlessly fascinating to work at Seagate with all of our partners.
Fantastic. That's great to hear. And one of the kind of final points I want to pose to you, because we're a little bit pushed for time now, would just be, and it's quite a broad question. It's quite a forward-looking question, but it does tie a lot of the elements we've chatted about today together to finish. And that is, Rob, I'll come to you actually to start, and I'll give you the last word in a moment, Andy. How do you see the relationship between AI and storage tech evolving in the next 5 to 10 years? Can you give me a quick snapshot into what that looks like, please, Rob?
As simply and as short as possible, we are going to keep generating more and more data on an exponential level with AI. And I'll just give you an example. There's all kinds of trends that go around the internet where people will jump onto the latest AI model and generate a cartoon of them and themselves and their friends doing something. And, you're talking about billions of images being artificially generated.
Yeah.
And now we actually have just recently some potentially really useful actually usable video generation tools, which is a completely different topic on its own and somewhat scary. I've been playing with them myself, but if you imagine a 5-second video is maybe, I don't know, could be maybe 10 megabytes or something. And now anyone can generate a 10 megabyte file, share it around. It's being stored somewhere. If I send it from my phone to your phone, it's stored in my cloud and your cloud. So now we've got data duplication, right? So I would imagine the amount of storage requirement, both on the training and the output side of AI, is going to be exponentially increased over the next 10 years, and to the point where AI is going to end up getting trained on AI images probably. So God knows what these things will be spitting out in the future. But yeah, so that's my opinion on the way things are going. I don't think hard drives going anywhere. We're just going to need bigger and faster storage as things go forward.
Andy, I'm going to come to you as well. What's your final word on this?
Yeah, so every market research report that we look at, the sum total of our major customer conversations point to that the size of data, let's call it, as a general thing, will be around 400 zettabytes in 2028. And that's gone up from about 10 zettabytes in 2010. Right? So, it is exponential growth for sure. The complexities of that will be quite difficult to overcome because the productive capacity of the storage industry isn't 400 zettabytes. It's some way below that. So there's this growing dichotomy. What do I keep? What do I delete?
Yeah.
And the technologies will be being developed that will help users decide which is which. And how do you keep more of what you've created? Because you've got all the expense of creating it just to delete it. And we think that's terrible. And we think it's a terrible use of resources. You can't keep on just making more stuff. And that's why we're heavily invested in high capacity hard drives, in platforms, in cloud, because we think that this is the most efficient way to store more. AI, I think, has tremendous opportunities. As I've already talked about, it also has tremendous challenges. I was listening to something today, and it said that most of the executive jobs are very highly paid, and most of the caring jobs are quite low paid, and it's the exec jobs that may be replaced by AI.
Yeah.
But it's not being yet, because guess who decides which is which? Is the executive class. But actually, if we were to turn around and make our carers the highest paid people, and we subjugated all of our jobs or all our functions to AI, then society would change. Now, what I'm describing is a utopia. Human nature gets in the way. But come what may, it's about data, right? Google have already said quite openly that we don't have the best algorithms, we have the best data, or the most data. And that's absolutely true. And we're seeing development of large language models for sure, but we're also seeing development of small language models, which will be industry or market or company specific. So there's a whole lot of things happening, and the questions we have to answer, the big questions are, how do we contain it all? And by contain, I don't mean limit, I mean store it all to make it available. It's certainly a big challenge, and I think that's why we're in business.
Yeah, it's a really exciting and interesting time ahead, and right now as well. So Andy, Rob, I want to just say big thanks for joining me on today's discussion. It's been really great to hear from you.
My pleasure.
Thanks, James.
Fantastic. And for everyone listening at home, I really encourage you to check out both Seagate and SecureLogic's websites. There's a wealth of resources and a lot of information building on the conversations we've been talking about today, guys. So thank you very much for listening.
Thanks, James. Cheers, Andy.
Cheers.
Thank you.